now we're going to practice combinations. So all of these examples in this video are going to be combinations, and I'm going to point out why they're combinations, because again, that's important to understand why. All right, so the first example, we have a group of 12 Republicans and 18 Democrats, which means we have a total of 12 and 18, 30. All right, 30 total people. A committee of 5 is to be chosen. So N is 30, R is 5. And a committee means order, it's just a random group of people. So that's what makes it a combination. All right, because we have to choose 5 people. If I repeat people, I won't get a group of 5. If I pick the same person twice, I only have a group of 4. And committee just means, you're a group of people that you're on a committee. So there is no rank. Whether you're first, last, you're still on the committee. So order doesn't matter. All right, so the first question, how many committees are possible? So this would be my total number of outcomes, the big group. Well, we had 30 people, right, total, right? If we pick from anybody, they could be Republican or Democrat. And we're going to pick 5 of them for a committee. All right, so 30, choose 5, and it's a combination, so you can go pick, you can use the formula, but again, almost all calculators are very rarely to find a scientific calculator that doesn't have a probability key. So use your probability key. So 30 combinations, choose 5. And again, since we have a lot of people, this is a fairly big number because, again, we start on off with a lot of people. And so that's how many total groups that there, different groups, different committees there could be. All right, again, there's that many because a different group is just one other person in the group changes the group's committee. Now, order doesn't matter. If it was ordering, it would be a much bigger group. All right, so again, this is just the combinations, different combinations of groups where order doesn't matter. All right, so now we're going to be looking for probability. So this is important to find the big group because that's what we're going to divide by. All right, find the probability. So remember, probability is the number in my event divided by my total number of outcomes, which we just found, right? Committee, suppose that, what's the odds, the probability that we get a group of all Republicans? So again, it's a committee, so order doesn't matter. But this time in the event, we're only going to pick from the Republicans. And so instead of picking from everybody, we're only picking from the 12 that are Republicans. We're still going to pick 5 for the committee, but instead of out of all 30, we're only selecting from the 12 Republicans. And so my event is still combination, so it's still committee. 12 combination, choose 3, and so for the Republicans there are 792 groups of all committees of all Republicans out of my total, so my probability would be that 792 divided by 142506. You could just type it in as a combinations in your calculator if you wanted to too. So you type in, your 12 combination, choose 3, divided by your 30 combination, choose. And I put 3, should have been 5. Can't read my handwriting. Choose 5. And you get the same ratio, and you can hit your fraction key, and it will give you out your fraction. Again, I'm going to leave them as fractions, because I'm assuming at this point you can write them as a decimal and a percent on your own. So I'm just giving you the fractions, 40 out of... So the simplified fraction would be 40 out of 7,917 possibilities. Alright, well, let's do the same thing, but now with only Democrats. So again, probability, so probability of my event over my total. Again, same total. This time, though, the event is I only pick a Democrat. So the total number of Democrats was 18. Still going to choose 5 of them for the committee. I still have to complete my group. I'm just completing my group with Democrats only. Alright, so 18 Democrats to choose from. We're going to pick 5 of them for the committee. So my event is 18 combination, choose 5. And so there's a grand total of 8,568 groups, committees of all Democrats if I had 18 and I'm picking 5. Alright, so the probability is that 8568 divided by the total 42506. Again, you could use the combinations 18 combination choose 5 divided by 30 combination choose 5. Just make sure you're careful when you type it in. Again, I hit the fraction key to give me my simplified fraction. Alright, and there's the simplified fraction. Or you can write it as a decimal print. Just make sure you're careful. Whatever the quiz, test, or homework asks for. If it asks for a reduced fraction, give the reduced fraction. If it asks for a decimal, make sure you give it to the decimal rounded however many places. If it asks for a percent, make sure you give it as a percent rounded however many decimal places. Alright, the last one of this example, or no, actually I don't think it's the last one of this example, it's just the last one on this page. Again, we're finding probability, so my event over my total contains exactly 4 Republicans and 1. So we're looking for a specific group. 4 Republicans and 1 Democrat. Alright, so I'm going to write out my event. I'm going to hold off on my total because I know what that is. So I'm going to find my event number. So I want 4 Republicans and 1 Democrat. Alright, so I'm selecting 4 Republicans and I'm selecting 1 Democrat. And so it is still combinations. The whole entire problem is combination. Doesn't matter what order I pick my Republicans as long as I get 4. Doesn't matter what order I pick my Democrat as long as I get 1. And so these are going to be individual combinations because I'm picking from this specific group. And so in this one, I'm picking a Republican. Well, I had 12 Republicans and I'm picking 4 for the committee. And then I'm going to pick a Democrat. Well, I had 18 Democrats, and I'm going to pick one of them for my committee. The and, remember, means we multiply. So here, it's going to be 12, combination choose 4 for my Republicans, and, so we multiply. 18, combination choose 1 for my Democrat. I have a group of 5, right? I always have to complete my group, right? I want a committee of 5. I picked 4 from the Republicans and 1 from the Democrat. Alright, so you do have to type those out individually. You could type them out all at once, just make sure you're careful. I put parentheses around them just to make sure you're careful. I'll find them individually, so I'll do the 12 choose 4 first. That comes out to 495 times the 18 choose 1. That's 18. It should make sense. There are 18 Democrats. I'm going to pick one of them. There are 18 options. Alright, then you multiply because it's the word and. I'm picking 4 Republicans and 1 Democrat. So you take the 495 times the 18, and that means there were 8,910 groups out of my total. So I've got to get my total here. Alright, so that's just the event. So probability is my 8,910 ways I can get 4 Republicans and 1 Democrat out of the total 1,000. Oops. 14506. I forgot a 2. 142506. Again, write that as the reduced fraction. 165 over 2639. Again, or decimal or percent. Again, follow the directions. More examples on the next page of the same problem. Alright, so again, still have 12 Republicans, 8 Democrats, still have a total of 20. We're still going to pick 5, and our total possible is still going to be that 142506. So just kind of hold on to that because it's the same group I will divide by when I do because that's the total possible groups of 5. Alright, find the probability that a committee contains exactly 3 Republicans and 2 Democrats. So this is a lot like before. I'm going to hold off on the total here. I'm going to find my event first and then do my probability. Alright, my event is I want 3 Republicans and 2, again, Democrats. I'm completing my group, but I'm completing it in this specific way where I get 3 Republicans and 2 Democrats. So now I'm going to pick for the Republicans and pick the Democrats using my combination. So for the Republicans, there were 12. I'm choosing 3. For the Democrats, there were 18, and I'm choosing 2. So this is combination 12, choose 3, times, because we use the word and, combination 18, choose 2. All right. Again, you could multiply that out if you want to. I'm going to do this individually, so this comes out to 220 times 153, and so my event, when I multiply those out, comes out to 33,660. Alright, so there's my event. That's not the answer, right? So we want probability Probability is my events divided by my total numbers. The event is 33660 divided by that total 142506. Oops. And so when I write the simplified fraction, that comes out to 1870 all over 7917, or the decimal. I'll write out the decimal since I have it right here. 0.236 are around 3 decimal places. All right. Next example. Probability the committee contains at least one. There's that at least phrase again. At least one Republican. So that's my event. So again, I'm going to find my event first. So we want our number of ways to get at least. Actually, I'm going to set this up with the probability because it's the at least case. All right. Probability at least one Republican. Which means I get 1 or 2 or 3 or 4 or all 5. Remember, the easiest way to do the at least one case is to take 1 minus the no Republicans case, right? None, the 0 case. Which means all 5 are Democrats, right? Which we did that one before. If you go find, that's the probability. All of them were Democrats. We did that one earlier. So if we go back up and find the all Democrat case, only Democrats, that's this one. So the probability that you only get Democrats was the 68 over 1,131. Alright, so I'm going to pick that. If I can remember it. 68 over 1,131. That's what we're going to subtract by. So again, make sure 1 minus that. So make sure you put the parentheses around the fraction. If you write it as a fraction, it comes out to 1,063 over 1,131, or again, that one as a decimal comes out to 0.9399, or 94% chance. All right, so reminding you, decimal percents fraction. All right, now this one I believe is the last one. Suppose there's one person named Matt in the group. All right, they didn't tell us if he was a Republican or Democrat. We just know there's one Matt in the group of 30. Find the probability that he's selected, all right, to be on the committee. So we pick Matt. We do that first. He's done. We've picked him. He's on the committee, all right? We picked Matt, and he's on the committee. So that means what's left, right? We have to sort of figure out what's left, and that's where my probability comes from. There were 30 total people. One Matt who's been selected, which means there are 29 people that are not Matt, right? And so we've got to finish our group with all the people. So if we've picked Matt, he's on the committee, which means what's left? What's left is there are 4 places left on the committee, and 29 people left that are not Matt, right? So we have the 4 spots left on the committee. I've got to fill with the people who aren't Matt. It's still a combination, but the combination has changed to now I've got 29 people to select and 4 positions left to fill because I've already picked Matt. He's done. So it's a combination. So this is my event. 29 people to fill 4 spots left after I've selected Matt. Alright, so it's combination 29, choose 4. That comes out to 23751. So there are 2,000. So this means there are 2,000. Sorry, I keep saying 2,000. There are 23,751 committees with Matt. That's my event. Alright, we want probability, so we're going to take that number and divide it by the total. So probability is our events over our total. Same total we've been using the whole time. So our 23,751 groups with Matt divided by our 142,506 total groups, which actually that simplifies to 1/6. Alright, again, I'm going to leave it as the 1/6. You can write it as the decimal percent. Again, whatever they ask you for, just make sure you're careful when you fill it out. Alright, next example. A box contains 25 transistors, 6 of which are defective. Suppose that we pick 6. So we have a box of transistors. 6 of them are defective. And we're going to select 6 at random. Alright. So I'm going to write this up. There are 25 total. That's N. We're going to pick 6. So R is 6. And just sort of put it out. There are 25 total. 6 are bad, right, defective, which means 19 are good, not defective. Just kind of putting out what we have there. Alright, we're looking for the probability. So again, we're going to take our event divided by our total. Alright, so I'm going to figure out total first. I'm going to do over here on sort of scratch paper. I'm going to figure out my total number of outcomes. What we're going to divide by. Total number of outcomes, which means we're reaching in a box. There were 25 in the box that I can select. I'm going to pick 6. And so the total number of outcomes possible would be my combination. It's combinations because it doesn't matter what order I'm selecting in, right? I'm selecting them. There's no rank. It's just it's like reaching in and grabbing out a handful of candy. It's a handful case. This is a handful case. I'm reaching in and grabbing 6 of them at random. Alright, so reaching in and 6 at the same time. There's no first, second, third, fourth, or fifth. Right? Order is not determined. Order is not important. Alright, so it is a combinations. I forgot to say that at the beginning, but that's why it's a combinations, because it's sort of like reaching in and grabbing out a handful. They're all picked at the same time. There's no first, second, third, fourth, fifth, sixth. All the same group. 25. Combination choose 6 would be our total. Oops. 25 combination choose 6, which I haven't right now. So 25 combination choose 6. Type it on the calculator. A really big number. 177100. Alright, so there's our total, which we're going to divide by for this entire problem. That's kind of why I did it over to the side. Alright, so the event is that we pick all 6 defective ones. All 6 bad ones. Alright, so the event, I'm just picking the defective ones. There are 6 defective, and we're selecting 6. So 6, we're only picking from the 6 defective. Alright, so we're going to pick all 6 defective ones in my group of 6. Alright, so this would be a combination 6, choose 6. Well, when you do combination 6, choose 6, there's only one possible outcome for that, right? Combination 6, choose 6. Because you're picking all the bad ones. There's only one way to get all of the bad ones. And so this would be 1 over our 177100. Which again is a really small number. Alright, I'm just going to leave it as the 1 over our total. 1771. Alright, so there's the probability, the chance that you reach into a box of 25 transistors and you pull out randomly all the bad ones. Alright, there's just a 1 shot out of the total, right? There's a 1 chance that you reach in and grab all 6 bad ones at once. And it should be small. That's very slim odds to do that. Odds are you're going to get some good ones with some bad ones if you're just randomly picking out a handful. Because there's not that many defective ones. Alright, next one. The event that you get all good ones, right? None are bad. So, not bad. Well, you're reaching in and you're picking out all of the good ones. So, there are 19 good ones, right? You're still going to pick 6. So, the event is you're picking 6 of the 19 good ones. You're reaching in and grabbing a handful. The handful contains 6 of the good ones. There were 19 chances to do that in my combinations. Alright, so 19, choose 6. So the probability is whatever 19, choose 6 is. I need to figure out what 19, choose 6 is. There are 2, 7, 1, 3, 2 chances in my event. So there's my event. So the probability is 2, 7, 1, 3, 2 out of 177100. Which I'm just going to write that as the decimal. 0.1532. If I write it as the decimal. So there's a 15% chance. Still not a great chance, but it is higher chance to pick all good ones versus all bad ones because you have more good ones, right? You have 19 good ones to choose from versus 6 bad ones to choose from. Alright, next example. There's the at least case again. That's my event, so probability to get at least one bad one. Well, that's 1 minus the probability that you get no bad ones, which is the last example we did. So 1 minus the previous answer. Again, I'm going to write it as a decimal. 0.847. So there's about an 84, almost 85% chance you'll get at least one bad one if you reach in and randomly grab 6 out of this container, out of this box. Alright, the last one, and this one we haven't done a more than. Alright, so this is my event. More than 4 are defective. So more than 4 are defective would be 4 or more are bad. Out of 6, right? We're grabbing 6 total. So that means you could get 4 bad ones and 2 that are not. Or 2 good ones. Alright, good. Or 5 bad ones and 1 that's good. Or all 6 are bad, right? 4 or more are defective. So 4 are defective, or 5 are defective, or 6. And I've got to remember, if I've got 4 defective ones, that means I still need to finish my group, right? I have to have a complete group. And so if I've got 4 defective, I need 2 that are not. If I've got 5 defective, I need 1 that's not. And then the last one, all 6 are defective, so 0 are not defective. Which actually, we did that case before, but I'm going to set this up again. So remember, ORs, we add, ands, we multiply. It is all combination. So combination, I get 4 bad ones. Alright, so remember, there are 6 bad ones. I'm choosing 4, so this would be combinations. Out of 6, I picked 4 bad ones, and then I completed my group. I needed 2 good ones, so out of 19 good ones, I picked 2. Or, so then we add, I picked 5 bad ones out of 6. So combination out of 6, I chose 5 bad ones, and, so we multiply, I picked 1 of the 19 good ones. Or, all 6 of them are bad. So that's the 6 combination, choose 6. There's only one outcome there, right? So you fill this out. So I'm going to do each one individually. So combination 6, choose 4. That's 15. Combination 19, choose 2. That's 171. Plus 6, choose 5. That's 6 times 19. Don't forget the plus 1. And so multiply and add carefully. My event is 2,680 outcomes. Right, that's how many outcomes in my event. So the probability is the event 2681 over that same total we've been using this whole time, which is that one, I can't remember, gotta go look, 177100. Alright, 177100, which comes out to be, if I simplify it, 134 over 8855, or 0.0151 would be very slim chances that more than 4 are defective if you reach in and grab out a handful. The last example, 5 cards. So this is drawing a deck of cards, alright? So we have 5 cards are dealt. So if we're playing a game and we're going to deal 5 cards, it doesn't matter what order your cards in. What matters is what your cards are, as a group, right? If we're playing poker or something, it doesn't matter if you get the ace first, heart last, whatever. It matters what's the group. So order doesn't matter in your hand. What order you're dealt the cards. What matters is the end result, the group that you get. So this is when we're playing with a game of cards, again, order is not important, so it's a combinations. Alright, how many hands are possible? So remember, standard deck has 52 cards. We're going to pick 5 cards at random. We're going to be dealt 5 cards at random. And so this would be my total number, which comes out to combination 52. Combination choose 5 is a really big number. 2, 5, 9, 8, 9. There is a lot of possibilities, right? Over 2.5 million possibilities. So I'm probably going to use this instead of typing this out every time. I'm going to use combination 52, choose 5. What's the probability? You're dealt a hand at all red cards. So if you get a flush, right? You get all red cards. Well, remember, half the deck. So this is my event. Half the deck is red, so there are 26 possible red cards. We're going to get 5 of them. So my event is 26 combination choose 5. Alright, that's the event. And I'm going to use that because, like I said, these are going to be really big numbers. So when I find my probability, right, it's my event over my total. And since the numbers are really big, I'm just going to use the combinations to type in. You can do this, just make sure you're careful. The event was the combinations 26 combination choose 5. Those are the red cards over all possible cards. So all possible cards would be 52 combination choose 5. And I'm just going to type it out like that, which it gives you the decimal 0.0252. So very slim chance. Or you can hit your fraction key then, which comes out to 253 over 9996. 3 nines and a 6. Again, however they ask you to write it out, make sure you write it out either as a fraction or decimal. Again, you have a fraction key and calculator, use it. Alright, find the probability. So again, probability is my event over my total, which again, I'm going to use the 52 out of 5 as my total. What's the chance my event is that I get a hand of all clubs? Alright, well this time the clubs is what we're picking. There are 13 clubs. So N is 13. I'm going to choose 5 of them. Right? 5 clubs. So my event would be 13 clubs, choose 5. That's my handful of 5 clubs. So when I go write this out, I'm going to leave it 13 choose 5 divided by the 52 choose 5. So 13 combination choose 5. There's the clubs. That's the event. Over my total, which was 52 out of 5. 52 choose 5. Alright, so there's my fraction. Very slim odds. 0.000495 would be the odds of getting a handful. Very, very slim to get a handful of all red. Sorry, all clubs. All clubs. Sorry, all clubs. Find the probability, which again, if you write that as a fraction, I'll write it out. That'd be 287 is the combination over the 2598960. Alright, the next one. The probability you're dealt a hand with at least 1 face card. So that's my event. At least 1 face card. So at least 1 face card. I'm going to set this up again with the 1 minus case. So at least 1 face card is equal to 1 minus the probability of getting no face cards. Right? That's my event that I'm looking for. And so I'm going to figure out the no face cards. This would be 1 minus the probability of getting no face cards over my total. Alright, when I fill this out. And so I'm going to figure out the no face cards. So I'm going to do the no face cards over here. So no face cards. If you remember from your deck of cards, there are 12 face cards. Which means there are 40 that are not face cards. Because there's 52 altogether. So if we take away the 12 face cards out of the 52, remember there are 52 total cards. If there are 12 face cards, and we don't want those, we throw those out, there are 40 that are not face cards. And this is what we're going to select. We're going to select 5 of the 40, so N would be my number of choices. R would be 5. So we're going to select 5 of the 40 that are not face cards. So the no face cards would be the combination. I'm going to select 5 of my 40 that are not face cards. That's the top part. Over my total, which would be 52 out of 5, which again, that's the total we've been using the whole time. If you type that out, and I'll write it out if you... That'd be 1 over, if you're writing out the numbers, that would be 658,008 divided by R2598960. Make sure you're careful when you type it out. That comes out to the decimal approximate 747. It's about a 75% chance of getting at least 1 face card in your handful. So if you're drawing 5 cards, if you're dealt 5 cards at random, you have about a 75% chance of getting at least 1 face card. 1 face card. Right, meaning at least 1 that's a jack, a queen, or a king. That's your odds. Alright, we'll stop there. The next one we're going to look at is the mixing all up. So that was combinations.